next session, Harnessing AI to Deliver Product Creation and Manufacturing Excellence, presented by Center for Automotive Research.
Neither good morning nor good afternoon or whatever noon is. Good noon to all of you, if it's close enough to noon, and delighted to see you all, and really honored to introduce a distinguished group of speakers here, panelists. I'd like to first call upon Dr. Fatma Kocher Poyraz, please. Thank you. Steve Bell, mind coming on? Binoy Damodaran, please. And Ken Royce.
Oh, should I have?
Go over one.
That way I'll get a seat.
All right.
Good afternoon, everyone. My name is Venkatesh Prasad. I'm the Senior Vice President of Research and Chief Innovation Officer at the Center for Automotive Research. And we are at a really exciting juncture here in so many different ways in terms of business decisions to be made, in terms of technology and what that is doing, almost independent of everything else, and where we're heading with respect to a lot of policy matters and how that influences how technology is applied and how business decisions are made. Today, we are here to understand just how best we can harness the power of one of the most powerful tools that are available to us in a highly democratized way. This is artificial intelligence. This is available at the palm of your hand on your favorite glass enabled devices, whether it's your phone or your iPad or anything else, and then at the same time also available to those who are able to bring data, aggregate data, and bring that to the power of everything that we want to do. So we are here today. We have a few minutes to understand how best we can harness the power of artificial intelligence, both for product design and delivery and for manufacturing. These two have to be done in a co-designed manner. And finally, of course, when you have a finished product like you see on the floor here, how can you use the power of artificial intelligence to be able to distribute products to create that final value that you want for the end user? And so without much ado, I'd like to introduce our speakers to really share with us a little bit. I've challenged them to speak in 120 seconds or so, because that's about the time that Abraham Lincoln took for the Gettysburg Address. So with that, Dr. Fatma Kocher Poyraz, please.
Thank you so much. I'm Fatma Kocher, and I work in Altair Engineering.
Would you like to come up here, please?
Oh, I see. Sure.
Yeah. Thank you. Yeah.
All right. Hi, everyone. I'm Fatma Kocher, and I work in Altair Engineering, leading the engineering data science team. For those who are not familiar, Altair Engineering is headquartered only 30 minutes away from here in Troy, Michigan. We are a 40-year-old company with 3,500 computational scientists. We've started in the computational physics domain, writing software for physics solvers, quickly expanded to high-performance computing, and in the recent 10 years, we've been focusing on data science. One of our badges of honors is that we're recognized as in the leader quadrant in Gartner Magic Quadrant for Data Science in 2024. With that, my background is multidisciplinary design, exploration, and optimization, and Altair is also known as an optimization company. And I worked in the auto industry before I joined Altair. In the last 7 years, me and my team have been focusing on leveraging the new technologies that are developed in machine learning, in AI, for virtual product development. So the name of my team is Engineering Data Science. You may be wondering what that is. As we start growing our data science team, software, and expertise in Altair, we quickly realized that data science, machine learning, artificial intelligence for virtual product development is a whole different beast than data science for any other domain. And then the reason is machine learning algorithms require tabulated data, whereas as engineers, we work with 3D geometric data. So the first task is to convert that 3D geometry to a format that data science machine learning algorithms can work with. One of the examples that you may be most familiar is converting 3D geometries to multi-view images and then using the pixel RGB values to represent that geometry. But that's, a very hectic process on its own, and there are many other methods that are developed in several industries. And our challenge is to look into those developments and see which ones we can use for product development. So the second challenge comes in our objectives. We want to use this data, 3D geometric data, to accurately predict the engineering performances of the applications that we're working, whether those automotive components, aerospace applications, electronics, etc. And in that accuracy, we are looking at capturing local stresses, which is a function of the local features of a design as well as global features. So to be able to capture accurately the physics, the engineering physics on this geometric data is the second piece of the puzzle. How do you convert geometric data, and then how do you accurately predict the physics? Because for us engineers, plus minus 10% may not be enough, right? We want to be as accurate as we can. And then the third piece of the puzzle for us was, how do we, as engineers, leverage these new technologies without having to be data scientists ourselves, without having to follow up the domain really closely, which is a job on its own, whereas we have our own responsibilities of developing products. So those are the three challenges we tackled in my team for virtual product development, and I'm really happy to be talking about those challenges today.
Thank you, Fatima.
I'm not sure if I made it in 2 minutes, but thank you so much.
Okay, we'll try the 2-minute challenge. TikTok.
So good morning, everybody. I'm Steve Bell, Chief Analyst with Wards Intelligence, which you may also know Wards Auto, that's been around for about 100 years. I'd like to put this into a framework or a context, because product creation and manufacturing is changing. I was at CES last week. You heard on the last panel, everybody was talking about the technology. But if you think of the automotive industry at this point of time, the software-defined vehicle has become a means of transformation. How do you go from the existing architectures which are discrete to a software-defined piece of equipment that the software defines the hardware? But what you have to look at is that the vehicle and the people in the vehicle are living in a context where there's exponential change going in their homes, in their workplace, in the environment, and even in health. And if you were at CES last week, you can see just down the side a number of the things that were happening. So the consumer's expectation, the consumer's needs are changing, and the automotive industry in the product creation process has to take that into account. We look at connectivity as a fundamental enabler of this. And on the continuum from the cloud to the chip, you've got data which is being moved, used, analyzed, stored, and transferred to other places. On the other side, you've got the digital twin, which is emerging as a fundamental in order to be able to shift left and also to be able to extend right. So as you start to think of new business models, it's now no longer about the car leaving the factory gate. It's about the vehicle over its life cycle and how do you continue to update that. So that is both a new form of manufacturing, it's software manufacturing, it's software updating, and creation has to take that into account. So where does AI fit into this? Well, it fits in a number of different ways, and this is why I wanted to sort of bring this out. Whether you've got AI occurring in the extend right in terms of the enhancements to the customer features, AI digital twins, looking at agentic AI services in the vehicle, looking at predictive maintenance capability, AI-supported software bills of material to enhance cybersecurity, And then on the other side, you have this real-time feedback capability, taking those lessons learned and putting them into accelerated design concepts with digital twins and also vendor supply marketplaces. So that's the framework that we've got AI transforming the industry. So it may not be 120 seconds, but I wanted to set the framework.
Very good, Steve. Thank you. Appreciate it. Binod?
Thank you, Stephen. Good morning, good afternoon. My name is Binoy Damodaran. I'm part of the IBM consulting team. I lead our data and AI practice that focuses on the needs of the manufacturing industry. That includes auto, aerospace, and manufacturing industries. So I'll just give you a quick glimpse. When we pay attention to clients in the industry, what are the prime capabilities that are emerging as you look ahead from 2024 to 2025, now that we've just started the new year? From a recent study that we did, here are 5 trends that are emerging as the top ones that enterprises are paying attention to in 2025, and I'll just briefly touch on 3 of them. Agentic AI, Steve just touched on it, is the newest manifestation of AI, is going to be used in your business, and it's going to require that your talent is trained on using it to enhance their productivity. Another one, there's going to be a rapid pivot of usage of AI in the enterprise, and it requires the CIOs to think hard about how to repurpose the budget and have AI deliver business value so that it's not just more investment, it delivers value and pays for itself. And lastly, there is going to be a big push. The CEOs are looking down at the businesses to deliver most value, but the business functions need to come together. I also will give you a glimpse of a study, Auto 2025, which is focused on auto industry. This is something we did jointly with AWS, Red Hat, and industry forums. Key patterns are emerging where the challenge of training the talent in the companies is clearly emerging. There is clear recognition of the SDV-based transformation of the product, but there is a big leap to be made from the current skills, which are engineering-based, mechanical engineering-based, to SDV-based skills. So overcoming these challenges are clearly recognized by leaders across the industry. Again, key takeaways from the industry from an AI perspective.
Thank you, Binod. Appreciate it. Ken?
Hey everybody, I'm Ken Royce from Infor. Want to talk to you today a little bit about manufacturing excellence, AI, and how do we make money at this? How do we help our customers achieve their business goals, meet their outcomes? Quick thing on Infor, we're 560 automotive customers we serve, 17,000 employees. Our key is, and I'm an architect, so I'm going to do architect speak with you here. So if you look at our design, everything is composable, it's modular. We run everything on AWS. We're all in with AWS. They're the only cloud provider we work with. And this is so we can go fast. It's about agility, it's about business flexibility. It's about building that framework so that we can leverage AI. I've met with customers for the last 10 weeks at 4 different shows, spoke to 300. The number one issue is they don't have the right alignment with their executives. Number 2 is they don't have access to the data. Number 3, they don't have the internal skills. Number 4, they just need a nudge on getting going. So that's what we want to do, is really help customers in solving problems and coming up with business outcomes. If you look at this wheel here, next level AI, machine learning, use cases for us for AI. We have 70 of them that we've built so far with our development teams, our data science teams, and it's all ties in. The anchor is ERP, right? So on the shop floor, we're looking to gather PLM, manufacturing execution system, MES data, and tie that in to achieve predictive and qualitative analytics of machine failure, equipment failure, such as things like that. The other one is really around the supply chain, is inventory rebalancing and being able to do a better job of forecasting demand and tying all this in together. Augmented analytics, it's really 2.5 use cases here. Augmented analytics is really about the tools, so you can dig deeper into the data and come up with more outputs and more outcomes so that you can line your roadmap and actually execute.
Thank you very much. We'll get started with some questions for our panelists here, and then we'll open it out to all of you in the audience. I have a question. Perhaps we'll start with you, Fatma. We'll start with you, Fatma, and then go on to Binod. It's really about getting ourselves grounded in terms of just what AI is and what its various manifestations, whether it's agentic AI or Gen AI or causal AI. So I think it'll be helpful to get a grounding just for purposes of our discussion today in the context of the automotive industry. So Fatma, just a couple of minutes, and a minute for you and a minute over to Binod, and then others can certainly respond to that. Just what is AI? How do you ground us in it?
So I would start with machine learning definition. Machine learning is basically a set of mathematical methods, processes that identifies the patterns, finds the relations between inputs and outputs to a system. Once you train a machine learning model that identifies the outputs given a set of inputs and embed that into a physical or a virtual product, that product becomes an AI product. Because from there on, that product, whether it's a virtual system or a physical system, can receive the inputs, predict what the output is, and make actions based on that output. Like an autonomous vehicle, right? It may see a slender structure or an object on the right side of the road. The input could be the image of that object. Using the machine learning model that's embedded in the autonomous vehicle, it identifies whether that's a stop sign, which then it stops and waits. It may identify whether that's a tree, then it continues, so it makes the action of continuing. Or it may identify that as a very tall person, and then it has to make the decision of stopping and waiting for that person to disappear from the environment that it's driving through. So, and deep learning is just another machine learning method. It's very good in finding relations or identifying the relations between very highly complex, multi-dimensional problems, but in expense of computation, expense that comes with the model training. But again, once you train a deep learning model and deploy it in a virtual or a physical product environment, that product becomes an artificial intelligence product. So that's sort of how I define it at a very simplistic way. It used to be that there was only supervised and unsupervised machine learning. Then there was, semi-supervised, self-supervised. Now there's generative AI, agentic AI, and then I'll pass the microphone to Binoy to maybe extend.
Thank you, Fatma.
I think you explained the foundational principles very well. I would just add, in the recent past, right, with the emergence of large language models, with mainstream manifestation through ChatGPT, but since then, everybody on a daily basis is able to touch AI, right? So that's the newest manifestation. So if you think of several decades of growth of AI, from data science to traditional AI, which is about 10 years old, to deep learning, about 5 years old, to 3 years ago when we first had generative AI, this is the newest manifestation. It allowed organizations to not worry as much about the training challenge because we have foundation models that are trained on massive volumes of data. So newest manifestation of it is combining generative AI with automation, with agentic AI, where digital agents can perform tasks for you. So this is the pattern. It's mainstream both in the enterprises as well as in products.
Thank you very much. Yeah, appreciate it. There's sort of one conundrum that we face as technology advances. You always have humans playing an important gating role. And so I'd like to sort of ask a question to start off with you, Ken. How are humans, whether you're a CEO or whether you're the line manager or whether you're the decision maker in between, how do you see your clients, your customers facing AI? How prepared are they? And so what's the role of the human being here, the human decision maker and the human ecosystem in being able to absorb the wealth of opportunities that AI offers and be able to bring that to you? So I'll start with you, Ken, but yeah. Steve, would you mind offering comments, and others too?
Yeah, pretty wide topic. So it's about alignment to start off with. Is your business aligned to your executive vision? Are your business outcomes clearly defined? And do you have a roadmap for getting there, right? So that's the first thing, is really more at the executive level. I would say on the shop floor, what I'm finding is fatigue. People get tired in doing quality or inspections. Those issues are due to eye strain, or you're just tired of standing on your feet, or the errors are made. We're human, right? So, and then as far as the technical piece of that, people don't have data scientists on staff, and if they do, they're not at the caliber they need to be.
Right.
And that's the biggest challenge, I think, is really from a resource and staffing perspective. Do you have the right people, and are you getting the right design on the front end so that whatever you build makes sense and aligns to your executive vision?
Yeah, no, absolutely. Thank you, Ken. Steve, about some comments?
Right. I mean, I think the thing I walked away from with over the last year, I've been working with Qualcomm, and if you look at what Qualcomm is doing to take large language models and put them onto chipsets, they are shrinking down. So effectively, you can have a small language model on an MCU that has 8 gigabytes of RAM. So now you're starting to see smartphones coming out with generative AI. You're starting to see laptops coming out with generative AI, which will be consumer focused, but they'll also start to be utilized in the enterprise for front-end design processes and for bringing lots of different data sets together in different ways, because it's a learning process. Then if you remember that chart I was saying, so you've got, that's going to occur in the health environment, it's going to happen in the manufacturing and in the workplace. Organizations are going to be driving towards, to the point that was made earlier on, they want it to be more productive, more efficient, they need to engage in the skills levels. So one of the aspects about this is that the human is in the loop, and they're going to be learning and they're going to be expecting. And so that was the point about automotive. From a design process, has to be aware that the expectations of the consumer when they get it into the vehicle now is going to be based on their experiences in the workplace, in their home. Alexa started to appear in vehicles because of the fact that Alexa was in the home. So now you're going to start to see things like agentic AI that you won't have to do an app. So basically, they'll say, it will know about you. So it'll say, Steve, I see on your calendar you've got this to do. And by the way, this shop is open here. You could get a coffee on the way. I've pre-ordered this. I know that you're going to charge your vehicle to get there. So I pre-ordered that. We know it's working. So you're not having to touch 15 different apps. It's going to do it as a service to you. So there's a lot of learning. And then now you take that and you put it into the workplace. So the designers are going to think about it. They're designing the new vehicles, but then you've got to start thinking about, well, those vehicles are going to be out there for 15 years, in some cases longer. So you're developing product that has to be enhanced as well. So you've got to build that capability into the vehicle. So I think that it really is a case that the consumer and the user and the worker are going to be collaboratively experiencing AI and move it forward faster.
Thank you, Steve. Appreciate it. This leads really well to another question I had, and this had to do with just how AI works with humans in a sort of conjoined manner. And so, Fatma, would you like to comment on that? This is sort of the hybrid intelligence, if you will.
Sure. So my focus is virtual product development using physics-based simulations and data science. And in that context, I put the value-added use cases of AI into 3 categories. The first category is augmenting engineers' toolkits, so allowing them to do things that they cannot do using traditional methods. The second category is increasing their productivity by reducing the non-value-added repetitive tasks. And then the third category is emulating expertise, which actually this hybrid intelligence falls into. So I want to give 2 examples, one from a study or a project we did with BMW on a crash case, and another one is one that we did with Ford Manufacturing for a manufacturing application. So in the crash use case, BMW is designing vehicle components they need to maximize the energy absorption, minimize the weight, etc. But there's also some subjective design criteria. Depending on the design, after a crash, the component could fold, which is an undesirable behavior, or it could do an actual crash behavior, which is a desirable behavior. But there are many designs that are in between, and only an expert can put them in the category of undesired design or feasible design versus an unfeasible design. And depending on the application or depending on the company, this categorization of feasible and unfeasible designs will change. And depending on the car vehicle, it will also change. So what we do here is we generate a large data set to be able to train machine learning models with, but the data set needs to be categorized based on the subjective design criteria. So there we use a unsupervised machine learning process called clustering. So the engineer, the expert doesn't have to go through each design one by one, but we can cluster the designs into certain, respect to their behaviors in post-crash mode. And then ask the expert to label them, whether that's a desired behavior or undesired behavior. So again, this is a gray zone in product design. And then once we have the expert labeling, we can train a classifier and embed that into an optimization process. So now our optimization process not only meets our objective criteria, like requirements on KPIs, but also subjective criteria, requirements on the design. So this is hybrid intelligence in the sense that the data needs to be labeled by the expert of the domain of the company. Another application is in manufacturing that we did with Ford Manufacturing, where an expert has been making operation setting decisions to minimize the scrap in a stamped part. And once that expert moves on to another responsibility and a junior engineer comes, that junior engineer needs to start the learning process from scratch. Whereas we can take the decisions that the expert manufacturing engineer has taken in the past couple of years, train a machine learning algorithm, embed that in the manufacturing system. So when the junior engineer comes, we can use that machine learning model to make suggestions on the settings to minimize the scrap based on the expert. And at least the junior engineer has somewhere to start from into their manufacturing process.
That's great.
So those are two examples of hybrid intelligence.
Yeah, well, thank you. Any comments, Steve?
Just to follow up, when I was in Europe at Electronica, there was a small software company that's just started up using Gen AI. But what they're doing is using Gen AI to take the code that was written originally for a lot of ECUs, where there's no documentation because the suppliers, and it basically automates the software development documentation process. And so if you start to think of all of the car manufacturers that have got, I think, the CEO of Ford said that, there's 150 ECUs, we don't own the code, but if we are going to centralize, you need to know what that code is. So now you've got a mechanism for hybrid automation, but you can also speed up your whole development process because you can use it for the new code that's being generated. And then you can take it one stage further, which is in the dealers and in the service shops, you're going to have to be able to provide documentation and coding in order to be able to service those vehicles going forward. So, and then it's not just about taking that documentation that's come out, but then turning it into visual training, notes that prompt them into maybe trying this diagnostic or this approach. So I think those hybrid approaches are going to change every aspect of the value chain as we know it.
Yeah, no, absolutely. Thank you. Yes. Ken, you said, if I heard you right, you met about 300 customers in the last couple of weeks. Could you give us a sampling, one or two examples of highly successful projects that might have been used with AI, or conversely waiting for AI to be used for success?
Well, I'll do the ones that I know that work.
Yeah.
So we're using AI right now to help customers with inventory optimization, as well as staffing, inventory rebalancing. The real, I think, the low-hanging fruit, and I'm going to say we're in Rev.1 of our AI extension of our business ERP and our other enterprise applications. But it's, I think, the quickest opportunities, the low-hanging fruit are going to be around inventory and resource management, some supply chain visibility as well.
Yeah.
Seem to be the areas.
That's very very interesting. I received through email a question from someone who heard this panel was being set up, and he asked, is there a way to use AI to get a better sense of inventory, specifically finished products, vehicles on the lot, so dealers can do their planning and reduce vehicles on the lot and figure out what mix of vehicles to have. So maybe others have comments. Binod, you?
Yeah, sure.
Start with
I think that problem was significantly manifested during COVID, when
exactly.
all of the dealers were struggling to get inventory and give customers visibility to the ETA of when the vehicle will be available to them.
Right.
So absolutely there is a huge opportunity. We happen to have worked with one of the biggest Japanese OEMs to completely transform their supply chain, and it takes different layers, right? So it starts with looking across the supply chain, understanding the events that occur, building a robust real-time data foundation that tells you the events occurring from dealers committing to a vehicle, to manufacturing, confirming production, to the movement of the vehicle, be it on a truck or a train or a ship if it's coming from different places. To that, if you add visibility and events as the product moves across various touch points in the supply chain, you can use predictive algorithms and use the configurations that customers are making in the .com to inform what options you produce, and movement of material, finished goods, will help dealers predict the ETA with much more intelligence and smaller windows of predicted. So that is absolutely something we've had a chance to do, and it's basically allowing a lot more transparency on product availability to the consumers, and allows dealers, if the products are in different points, they can exchange, right, dealer groups, so that the right product is available to the right customer. So very relevant both from analytics and AI perspective.
Thank you, Binod.
Prasad, if I could just add to that.
Please, yeah, and then we'll get to the audience.
To your point about the COVID, right? And we found out the semiconductor industry, the demand dropped, semiconductor moved product elsewhere, but it's a mindset change, because everybody's talking about software-defined vehicles, and that's about centralized software. But the company that didn't have any problems during the semiconductor supply situation was Tesla, because their software defines their hardware, not the hardware defining the software. So they could see what was coming, and they could switch the suppliers much earlier. So they were the only ones that didn't have an inventory situation. So I think as we start to look forward, one of the key aspects is understand that software-defined vehicles isn't just about software. Some of the best hardware engineers are actually going to be software engineers, because it's about defining the hardware to deliver the software performance going forward.
Yeah, no, absolutely. Thank you, Steve. I would like to open the floor to questions. If there's anyone there, raise your hands. You could come up and go ahead, please.
Question involves consumer protection.
Would you like to just introduce yourself, say
Yes.
your affiliation, and then,
Chris Hood, Transcontinental Media, Fort Lauderdale, Florida.
Thank you.
So I'm a former employee of LexisNexis.
A little louder, please.
I'm a former employee of LexisNexis.
Yeah,
And
great.
as you may or may not know, there is a major multi-jurisdictional lawsuit happening right now with General Motors, LexisNexis, and Verisk. Basically, it accuses General Motors of wire fraud. There's over 30 cases involved. There's another one by the State Attorney General of Texas involving 1.9 million motorists. First lawsuit involves 19 million motorists. Their data was acquired without permission. I would like to know what this industry is going to do to protect consumers. And I want to elaborate a little bit further, because this data at this stage was taken out of context. In other words, they tapped into people's cell phones, they tapped into their vehicles without their permission, and used that data to monetize it. In this case, it was to raise insurance rates. But just to show you how far this can go, let's say I go to McDonald's every day, and you capture that data, you send it to my health provider, up goes my insurance rates. So I want the industry to answer the question, what do you do to protect the consumer? And in my opinion, there needs to be a warning label on some of this stuff because there's a lot of consumers out here who don't want you touching their data, don't want you ordering their coffee, and they don't want you to tell them where to go, where they've been. Can you answer that for me?
Okay, thank you. I guess the broad questions, the sentiment and the underlying questions on data privacy and how that's used and how it's monetized. And so anyone wants to offer comments on that?
I can start. Extremely critical, sensitive need that needs to be addressed and done in a far more responsible manner. I can tell you multiple OEMs, so I'm very familiar with the lawsuits you're talking about. Multiple OEMs are recognizing the need for what I would call responsible adoption of AI because there are multiple dimensions to it. What data are you using to train the algorithms to offer a personalized service, right? Did you get the right permissions? To your point, did the person opt in, right? Did they offer their data so that they can get a personalized experience? The other thing is what algorithms did you use? Were those algorithms trained on legitimate use of data that was used to train the algorithms? So there is a clear pattern that is emerging where the chief privacy officers, chief counsel, and the CIOs are coming together to understand how they can adopt AI in a more responsible manner. So those guardrails were not as hard as they needed to be, but now, to your point, with a lot more sensitivity and regulations, both in Europe, Asia, and various states in the United States, there's a lot more accountability that the product owners have to meet. So there is a recognition of how do we do this in a responsible manner, and everything from putting guardrails from our data management and the people who are designing new products, how do they keep in mind who the consumers are, have they opted in, and can we make products that are based on their permission? So those wheels are moving, but the journey this far requires a lot more improvements.
You're basically saying there's really not adequate consumer protection at this moment. Because right now, I can tell you that data is being captured without consumers' permission. So I think the first thing the industry should do, we've talked about a lot of things here today, is protect the consumer.
Yep.
Thank you.
Yeah,
We agree with you.
Yeah.
Agree with you.
Appreciate it. Any other questions, please? If you could hold a little closer to the mic, that'd be great.
Hi,
That's good. Better. That's good. Speak loud. That's good.
Simone Bonino.
Money.
So thanks for giving us insights. I think you explained really well, particularly the new product development and product design and the influence that AI is already having.
A little louder, please.
And the influence that AI is already having on that side. My question is more on the manufacturing side, and particularly when dealing with the supply chain and maybe with outdated equipment. And is that going to be a barrier of implementation for AI, or maybe there is a way to still implement AI even down in the supply chain, even when they have more traditional equipment? I'm thinking maybe combining AI with digital twin, but what are your thoughts on that?
So, are there limitations in the application of AI to supply chain?
Yeah, I mean, I could take an initial pass and others can wait.
What else? Yeah.
One of the addicts, the former CEO of our company used to always use, she used to always say, there is no AI without IA. If you don't take care of your information architecture, which is the source of truth, which is where the data resides, it can constrain you, right, of what you can get out of AI. You touched on supply chain. Certain domains in an enterprise have simple data types that are easy to use, customer experience, marketing, they have text, and then you have text-based insights. Supply chain, manufacturing are multimodal. Your data is a combination of time series data, textual data, so that becomes more complicated. So to your point, the information, there is real work to be done to improve the information architecture, improve the management of data. Not that it needs to be perfectly organized. Today's tools allow insights across without physically moving the data. But yes, there is a work that needs to be done to make the data available for the algorithms to use. And then there are faster techniques available. Dr. Fatima touched on some of those that allow you to get insights faster. But yes, the supply chain manufacturing are complex, and for the right reasons, they will have the biggest impact within the industry when they are addressed.
And it's about the data, right? Getting access to the data is the #1 challenge. And I can't think of a standard business process that can't be leveraged and made more efficient with AI. I don't see it. Over time, AI will improve process for everybody in every process.
Thank you, Ken. Thank you, Binod. So maybe we'll just go around. We just have a few minutes, 5 minutes now. So it's just a final lightning round, if you will. Ken, if there's something you want to share with the audience that you haven't already, now's the chance. And then
Yep. So I have 33 use cases on a YouTube channel. So if you want to come after, what I didn't communicate during this session, come see me. I've got a YouTube channel with 33 use cases of AI, how to use AI, and what we've done and what's worked and what hasn't. So
thank you.
Come see me on that.
Appreciate it. Binod?
I would say the biggest thing we are seeing is there are so many emerging capabilities in the marketplace. It is very difficult for both human beings and enterprises to keep in track. The only thing is we have to be continuous learners, curious, because the techniques and patterns are going to be there. You have to have the human in the loop, at least today's manifestation of AI, because the human is the consumer as well as the expert. So one, be hungry, learn, and that is the only thing we are asking all of our enterprise customers to continue to train their employees and continuously keep them abreast.
Thank you, Binod. Over to you, Steve.
So if any of you were here yesterday, you may have heard Governor Whitmore saying it's a challenge and a fight. We need to keep the jobs in Michigan. There's 1.5 million jobs that are dependent on the automotive industry. Manufacturing is a significant part of the US GDP, and automotive is a significant part of that manufacturing base. Our sister company, Omdia, did a study of where AI in manufacturing is. And what they found was that Asia and Oceania, 81% of the manufacturing companies are employing AI, and 45% of them are doing it at scale. When you look at Europe, it was 41% that were applying it, and 12% that were doing it at scale. In North America, it was only 38% of companies that were doing it, and only 17% at scale. So I think that if you take those statistics and you start to think about the urgency with which this needs to occur, then it's not about the number of people that you apply. It's about having the right people, the right skill sets. Writing software doesn't take a large team. It takes a really good team with focus, structure, architecture, access to the data. So you've got to understand the system of systems that are involved in manufacturing, and particularly in an OT versus IT world, how do you transition that? So I think there's a challenge, and I think there's a race, and we've got to get that moving quickly.
Thank you, Steve. Fatma?
All right, I have 2 points to make. One is more generic, one is more technical. So for AI to flourish, you need data, but you also need domain expertise, right? Without the domain expertise on a topic, no one formulates a good problem, and no one is able to curate the data that is required for developing good, effective AI applications. So if you have domain expertise, you don't have to be a data scientist to be able to effectively use AI. You can find data scientists, but domain expertise is one that you always need. The other one is I want to bring out this other method called geometric deep learning, particularly for those who are working in virtual product development. There's a lot of buzz about other methods in the domain, but I find that geometric deep learning is going to be one that's going to revolutionize the virtual product development by enabling CAE experts to use historical simulation data to train machine learning models that can fast predict engineering performance as well as generate new designs.
Thank you, Fatma. We have about 55 seconds. I'll just summarize in a super lightning round. Access to data is key. You need to be able to understand IA, the information architecture, before AI. Everything's connected. It's beyond just the vehicles, but vehicles have a whole life to do, not just the production and distribution, but the entire life cycle of the vehicle needs to be managed. And then Fatma, there's all kinds of new technologies and theoretical constructs that are helping out, including geometric deep learning, that's coming to us. And so we got to figure out how to use that and grow with that and benefit from that. Thank you all. And with that, we'll give you back 20 seconds to do whatever you'd like to. Appreciate it.
So much.
Thank you, Ken. Appreciate it.
Thank you, Prasad.